what was the last thing we have discussed last course? Okay, so let's put here the last topics. So here we discussed about the has a relation, and I showed you all different combinations. So has as one-to-one or one-to-many. Okay, and here I showed you what happens if you use a static array, a dynamic array, okay, and what happens if you don't have the default constructor, that here you need the dynamic array of pointers, okay, and you have the source code on Git where I showed you how to manage that, okay, because if you don't have a default constructor in the class you are using, then this is the only way to overcome the fact you don't have a default constructor. So dynamic array of pointers to objects. Okay, so this was the, let's say, the discussion we had last on Monday, and we cover all these cases, and especially the relation between constructors, because this is what the has a relation brings. It shows you how you can combine multiple classes in order to create a new one, but then after you do that, it's it's a class in the end. So everything we have talked till now, constructors, copy constructors, setters, getters, constant, statics, it's still the same. Okay, so the only difference is that now you have a class which has an array or one object as an attribute. That's the only difference, and I showed you how to handle the constructors relation. Then we also started the discussion on ISA, which we finished today. Okay, and generally here we will focus as inheritance from only one class. I will just give you another example of multiple inheritance, which is allowed in C++, but what you want to understand is that multiple inheritance is not something we want, and because it can create many issues. And this is the reason that in all the programming languages you will do in the next semester, which are object-oriented, like C#, Java, you will not be able to use multiple inheritance. So that's why I don't want to insist on this topic. I will just show you what it means, and I will just give you one reason out of 1 million reasons why you should not do multiple inheritance in C++, because this is one of the few OOP languages which allows multiple inheritance. So here I will say as one-to-one inheritance. Okay, so multiple inheritance, why not? Okay, so I will give you reasons why not to use it. Okay, because in Java, C# you can't. Okay, because they realized it's like opening the Pandora box. You'll create more issues rather than to solve issues. Okay, so let's start here with this class. So I want to do inheritance. Okay, so what was the context? And what is for today? So today course, what I want to show you is how you can use inheritance to be very flexible. So again, here we will talk about inheritance. And what I want to show you is how you can build frameworks of classes. Okay, and how you can manage them in a very simple way. So here we will talk about upcasting, okay, and downcasting. Okay, and in order to make the magic work versus downcasting, I will show you the magic of using virtual methods. So virtual functions. Okay, so these are the topics for today, and they are all related with inheritance, which is a very smart and flexible tool that we have in OOP in order to create complex programs in a very simple way. Okay, so let's start with the premises. So in order to have inheritance, let's say I have this student class. Okay, so I have the student class, and here I have a name, string name, and let's say age. Okay, and let's introduce here the two libraries that I need. So include string and maybe IOStream. Okay, and let's use using namespace standard. Okay, so I have the student class which has a name and an age, and here let's say I also have a faculty. Okay, so here I have string faculty. Okay, so because this is a student, okay, so you are enrolled as at a faculty. So here, okay, you have on the, let's say, public space, you have all the stuff that this class should have, like constructors, copy constructors, getters, setters. Okay, so right now I can create a program in order to manage students, right? We know this. So let's say this is student John. Okay, and now I can play with students and I can also have arrays of students and so on. Okay, so why do I need inheritance again? So we will start the discussion from this point. So why do I need inheritance? Because many times you realize that once you develop this solution, which works for students, later you realize that you can make it better. You can make it do more than managing students. So for example, let's say we deliver this for a faculty. So we create this solution for a faculty and they are happy about it. So we manage all their problems, all their use cases using this class. But later they say, hey, after 3 or 4 years, we have students which graduate and then they enroll for a master program, right? So here, if you say you can have a, let's say, bachelor program, so this is you at economic informatics. Now, how do you change this in order to manage students which are enrolled as a master program? Because now you have new data, you have new courses, you already have a bachelor degree, you already have some data which is in the past. So as I told you on Monday, if you are here in C and this is a structure, then what you do? You change this structure in order to add the master program data, which is very counterproductive and it will create a lot of issues. So in OOP, they said, hey, once you have a class which you developed and is tested and you build a solution around it, now you can actually enhance it, you can improve it by adding new stuff without actually changing it. So this is the inheritance. Okay, this is the easy relation we started talking on Monday. So here I will say this is a master student. Okay, and in order to make the master student inherit everything you have here, including the methods. So for example, here if I have a, let's say, get name. Okay, let's put a simple getter, return this name. Then I will also inherit the attributes. Okay, so how do you do that? You don't copy paste this here and here, you do this automatically. And this is the inheritance mechanism. So what do? You say that, and this is the syntax specific to C++. For example, in Java, they replaced the two dots with extends. Now in C Sharp, they kept this. Okay, so you have different languages, programming languages, which have different way to say that the master student class extends or inherits student. So this is the correct verb. So here we say master student. Okay, so master student. You can say inherits or extends. Now extends is more specific to Java. Okay, because in Java you have extends as a keyword. Master student inherits or extends student, but this is the correct way to say it using the right vocabulary. Okay, so here I will say this one extends student. So right now, all the data you have here is also available to master student. Okay, so in order to prove you that, let's create a master student. Okay, this is again what we did on Monday. So Alice is a master student, and now I want to say, hey, I want to see Alice's name. So I know that a student has a getter, and I want to use it here for Alice. So here I will say cout and line, and here I will say Alice's name is, and here I want to say Alice dot get name. And if I try to do this, what I will get, it's an error which we already have seen many times. It says the getName function, which you see here says it's from student, is inaccessible. but it's not saying there is no get name function. For example, if you have a typo here like this, get num, you see the error is different. It says there is no get num in master student, which means there is no function. But you see here, it does not say there is no get name. It says is inaccessible. Why? Because every time you inherit something, they have this mechanism where you can use the same public, private, and today we see protected, which are called access specifiers, in order to tell to the compiler how you want that the compiler to do copy paste. So what happens when you say this? What's the explanation? Why it says is inaccessible? Because what actually happens, you need to imagine this. You have the default private here, and now the compiler takes everything and copy paste them here. You don't see this, but everything which was here, now it's copy pasted and it becomes private. Okay. And that's why you get the is inaccessible. You see? Because this is what actually happens when you inherit. The compiler does this copy paste, but we don't do it. Okay. For us, it's invisible. So every time you inherit, by default, you inherit in a private way, which means everything which was here goes into the master student, but is private, is becoming private. So you can't use it here in main. So this is actually writing this, which no one does. Okay, so when you inherit in C++, you can say how this should happen. And by default, if you don't write this private, you get it for free. So how do you inherit anything from here in order to keep it as it was? Like, I want get name to still be public also for a master student. So here you say public. So remember, when you inherit public, you don't make anything public here. You keep them as they were. So now I have a get name here, but if I want to still access something which was private in student, like the name, that one is still private. You see? So if I try to get to the attribute, this is still inaccessible. So what was the conclusion? That generally, when you inherit in C++, you generally, most of the time, you will want to keep everything as it was, especially the public interface. So that's why you will do the inheritance in a public way. Okay, so right now I inherit everything. So what was public here, it's public also for a master student. And what was private here, it's private. Okay, so when we talked about public and private, I told you that there is a third one, which is called protected, which will make sense only when we have inheritance. So let's see what protected does. So for example, here, let's bring some new data. So here I will say string master program. Okay, and let's say we have another string, which is the master faculty, because you can go and do a master program at another faculty or another university. Okay, so you can choose any other master program. So a master student will have this new data besides the normal data for a student. Okay, so let's suppose here you want to do this method, which is called print or display. Let's call it display. So you will understand the protected specifier. So here we want to say this. Hey, I know I inherit everything from here. So in the display method, I want to show that a master student has a name, age, faculty, a bachelor program, which that master student graduated, and then the master program. So here I want to say this, cout and line. So I want in the master student to have a display method in order to show all the data of a master student. So let's start with name. Okay, and here I will say this. And here I want to say name. But you see, the IntelliSense is not showing me the attributes. It's showing me master faculty, master program. It shows me display, which is this method, and it shows me only get name. So let's say for get name, I can use get name because I have this getter here. But what happens for age? Because I don't have a getter. But in the same time, this is frustrating. Why? Because a master student, based on what I just told you 5 minutes ago, it should inherit anything from here, which means a master student has a name, age, faculty, and bachelor. So why, if we inherit that, we can't get it, right? It's frustrating because you said you will get it, I will get it, but I don't. So what's the error here? It says, hey, you have an age in the master student, but is inaccessible. So this is very strange because we are used to write functions here in our class which can have access on the private, right? That was the rule. Any method inside your class can access any data anywhere, like the master program. But what I see is that when you inherit, by default, you don't have access, despite you have it, but you don't have access on the stuff which was private here. You don't, because this is encapsulation. So what's the conclusion? If you define something private here, this is always private, including for any class which will extend that class, which means you can't break the encapsulation concept. Okay, which means if you define here private and you say, hey, only the student class has access on this, that's true no matter what you do with the student class. So if you have a class which extends student, that class will get the age and the name and the faculty in the bachelor program, but will never be able to access them directly. So this is frustrating. So in order to, because why is frustrating? Because it makes sense and is not making sense. So I understand the idea with private. Okay, so I understand that the fact no one here in main should be able to access anything which is private in John. Okay, only by getters. But hey, this class is not just any class. It's a class which is related with us. So this class is inheriting students. So is that it's my child, right? So I'm student and the master student is my child. So why this class, which has this very special relation with the student, cannot be allowed to access these attributes, which now you also have in master student? So because this should be let's say be possible that a class which inherit another one should be able to access the private. That's why when you design a class, if you think that in the future your another class will inherit this one, and you want to allow this one to have access on everything you define here, that's why you should use, instead of private, you should use protected. So protected is the third access specifier which exists besides public and private, and it has this unique role. Protected for anything else, any other class which is in no relation with the student, which like I don't know, class professor or class faculty or any other global method like main, protected works like private. So for example, if you here you want to say John age is, and here you say John.age, protected is like private. You see it says is inaccessible. Okay, so protected works in the same way as private, but for any class which extends or inherit that class which has protected fields or methods, protected is like public for this class, because you have this special relation between a master student and the student. Okay, they are not so just two classes, any classes. Those are two classes which inherit each other. So you see now, after I change the private to protected, now here I have full access on name, age, and anything else there, like faculty and faculty. So this is protected. So up to this moment, protected has zero meaning, but in inheritance, protected is something which gives access to any class which extends student, direct access on those fields, but they are still private for anyone else. So if you ask me, if you design classes and you think that in the future you will extend them because you will grow the solution, I think you should go for protected, okay, to make your attributes protected, and maybe in the future you will inherit and extend it, okay? So this is protected, and in this way we give access to classes which inherit that class, okay? So this is the program, okay? And the rest follows with the master faculty, and here it's the master faculty. Okay, so now you see I still keep name, age, faculty private, but for a master student, they are available. So now I can use, now in outside the master student, name is still private. So protected means you have access on them only here in this class. But if you move outside the class, protected is still private. So again, you have full control over that. But now I can say Alice.display. So now I have a public method in here in the master student, and now I can display the data. Okay, so this is protected. Okay, so this is the what we do. So let's add it here because that was the topic. So protected. Okay, so this is the explanation, and that's why we will use protected from this point on. Okay, now what was another issue which I showed you on Monday? The issue is with the constructors. Remember the relation between constructors? So here in main, I have student John, and here I have master student Alice. But what happens if you don't have the default constructor here? So let's say here I define the constructor which requires the name and age. Okay. And here I will say this name equals name and this age equals age. Okay, so when you do this, now this is a breaking change. Now you have an error here and here. Now this one, it's easy to fix because now I will just call the constructor parameters. Okay, but here, how do you fix it? We already have seen this also for the has a relation. So here it says there is no default constructor in master student. So I showed you how you deal with this. So when you don't have the default constructor here, now it's mandatory if you still want to provide the default constructor for the master student, you need to write it. So you don't get it because this is what the error says. And now, in order to, now you see the error has moved here. So now I don't have any error here, but now the error is here and says no default constructor exists for student. So as we did for the has a relation, in order to say to this constructor, hey, there is no default one here which you can use for free. Now you need to use this one. This is something you need to write because the compiler will not be able to call this one. So here you need to say, hey, there is a constructor in the parent class which requires the name and an age. So I need to give you the values for those. Okay, so this is how you create this relation, because right now in order to create a master student, you rely on the student constructor in order to do your job. And obviously if you have a constructor here which receives values for name, age, and maybe the master program, then you can use those values, because again you'll have the same error, there is no default constructor there. So this is like working with constants. So here again, but now you have some values. So here you will say name and age. So I will take these values and use them here for this constructor. And then what's left, I will use it for the master program. Okay. So this is again what we have seen on Monday, how the relation between constructors, especially when you don't have the default one, is managed now by you in order to fix this error. So right now I can say Alice will have the John Doe and 0 age, because this is what happens with the default constructor of master student, which is used here. So now you see the name and the age. And I can now use this one. So for example, I can say Alice of Alice 22, and let's say informatics. Okay, so right now I'm using the second constructor, which will take the name, age, and store them using the parent class constructor, the student, into the name and age attributes which are inherit from here. And then I use the master program in order to initialize the attribute which is specific to the master student class. Okay, so if I run this program, I should see that the name is Alice, age is 22, and the master program is informatics. So if I run it, okay, this will prove that the data is stored in the right place. Okay, so let me show you the output. Okay, so here it is. Okay, so name Alice, age 22. We don't have a faculty in the program because we didn't initialize them, but I see the master program informatics. And again, I don't have a faculty. Okay, so this was the things we covered on Monday. Okay, so now let's move to the new stuff. Okay, so how can I build frameworks of classes? So what do you have here? This is a framework of two classes. And if you, in the next year, next semester, you will have a course for designing programs. And then you will learn how to use UML as a design language to design your solutions. And then you will have a class diagram, which shows the relation between different classes in your program, in your solution. And then you will say, hey, I have this framework of classes and master student extends a student. Okay. Now I can also do another class. So just to show you how you can create this framework easily. So here I will say, hey, I have a PhD student. So maybe some students will continue their education after the master by going to a PhD. And here I will have the, let's say, PhD program name. Okay. So now I have another class which extends the master student, which means now a PhD student has everything that you inherit from your ancestor, like name, age, faculty, bachelor program, then what you inherit from master program, master faculty, and then the new stuff. So now a PhD student has everything. Or you can say, hey, at the bachelor program, we have Erasmus students. So here I have an Erasmus student, okay, which extends a student, okay, and an Erasmus student as data will have only, let's say, the country of origin, okay. So it has name, age, the program at which the Erasmus student join us, and then you have the country of origin of the Erasmus student. So if I will draw this stuff, I will open Paint just to show you the framework that we just created. And now we are flexible to do whatever we want. So let me open Paint and share this with you. 1 second. Okay, so let's share Paint because this is the way I will draw this. Okay, so what do I have? At the base of our framework, I have a class which is a student, okay, which has name, age, bachelor program. Okay. 1 second. Another software just open on my screen, which is annoying. Okay, program. Okay, let's extend this and then the faculty. Okay. Then from this class we extended, so this is student. Then we extended the master student. No, 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 no. I hate Paint. It just deleted everything. God damn. Okay, so have the student. Okay, so here I have age, name, bachelor program, and here I have faculty. Okay, then from this class we extended here, let's say, and here we had the master student. Okay, so this is the master student. Let's also use black. Master student. And now the master student brings, but it's also inheriting all that stuff. It brings the master program and master faculty. Okay. And you generally in UML, you do this by drawing a line saying, hey, this inherits that. And from the master student, then we extended this even further into a PhD student. Okay, and let's draw the line here. So this is the PhD student. Okay, PhD student. And here I have the PhD program. But in the same time, we draw another class which inherited the student, which is the Erasmus student. Okay, so this one extends the same student. Okay, and here I will have this is the Erasmus student. So what do you have here? This is a framework of classes, Erasmus student. And here you can easily see the relation between all these classes and what they inherit and how. Okay, so this is the framework of classes that which will help us create an application which will manage any type of students. And every time if we want to add something new, instead of changing the existing classes, which we will extend them. Okay, so we will create a class which will manage a specific use case in that solution based on the reality. Okay, so this is the framework of classes. Okay, so this is a framework of classes to manage students' data. And each class here inherits, which means gets all the stuff that its parent and its ancestors has. So a PhD student has a PhD program, it has a master program, a master faculty, it has a name, age, name, bachelor program, and faculty. Now, an Erasmus student has a country and only this stuff here, because an Erasmus student inherits directly from student. So this is a framework. And in this way, you can easily now create more and more complex programs by focusing each time on a specific thing. Okay, so you don't need to do many things. Okay, because you just need to focus on a PhD student and an Erasmus student. Okay, so what inheritance allows me to do? It allows me to scale up easily the solution in order to cover more complex ones by building frameworks of classes. Okay, so it's easy to do that, right? You just extend classes and then new attributes and then you focus on that class. Okay, so what's the issue here? The program will become more and more complex because now instead of having only student type objects, now you have master students, PhD students, and Erasmus students. So how do you handle that? And this is where the upcasting and downcasting help us. So how do you handle all these types of students? So this is the question. So how do we handle all types of students? So what will be the first idea? Let's see if that works. So for example, you will say, hey, let's create an array of students. So all our students will go into an array. But for that one, you will just see it. I need the default constructor from student. So here I will have student, let's say students. Okay, let's say we have an array of 10 students. And this is the error. No default constructor exists. So can you create this array without the default constructor? No. So let's put the default constructor in order to simplify this problem. So here, let's say student. Okay. So let's suppose we can do this. So I have an array of 10 students. Now, how do you handle your master students? Like the cybernetics faculty, you have bachelor students, you have Erasmus students, you have master students, and you have PhD students. So what do? You say here, master students, 10 or 100, 1000. So how do you handle your PhD students? You see the pattern? Each time, what do? You add a new array, which could be also dynamic arrays. Okay, I'm just focusing on a simple solution. So what do you need to do each time? Add another array. So now some of you will say, hey, that's not fun, because every time you add a new type, which we see it's very easy. Okay, so inheritance has its own advantages. Every time you add your own type, then the complexity of the stuff we need to do increases because we also need to add new collections, new types of arrays, new types of variables, which is true. So if we have a very big framework of students with like 10, 20 types of classes, different types of students, then the conclusion will be that you need to have 20, at least 20 types of arrays in order to store all that data, which is not something you like. I don't like. So how do you handle all these types of students? Obviously, not like this. So if I ask you, how many arrays do you want to manage? I think you will all agree that instead of saying 4, 5, 6, 7, you will say 1. Okay? So let's see if this is possible. So instead of having an array type for each class type, can I have only one to put everything there? This is the big question. Can I have only one? And if the answer is yes, the question will be what will be that type of each element. But let's leave the question for later. So let's focus on the first question. Can I have a single array to store all this data? Because if we succeed in doing that, that will be beautiful because I can have very complex frameworks with many classes related to each other, and I have only one array to manage all, which is great. So let's see what's the answer to this question. Is it possible to have only one array? So in order to understand why this is possible, because otherwise we will not spend time talking about something which is not, but in order to understand why this is possible and why this is not magic, so all OOP languages have this, will allow you to do this, it's more important to understand why, because you just need to understand how this stuff looks into memory. So if I will draw how a student looks in memory, you will see that it looks like this. You have this rectangle, which is the age rectangle. Then you have, yeah, I think it's simple to draw a big rectangle and here to draw lines. So for example, here you will have space where you store age. Okay, yeah, let's put it like here. So here you have age for integers. It's an integer. 4 bytes, it's an integer. Then you have space for name. Then you have space for bachelor program. Okay, and then you have space for faculty. So in memory, this is the way a student looks. It's like you have this box which has these small boxes which store the data specific to a student. Now, how the master student looks like, and this is where you realize that it's possible to get what we want. So if I focus on the master student, just let me move these toolbars. So I will just zoom a little bit. Let's draw the master student here. So if I will show you how the master student looks like, and then you realize why when you create a master student, you need the constructor from the student, because they made this decision. Anytime you create an object of a class which is something which inherits another class, in memory, this looks like this. So here it's how a master student looks in memory. When you create a master student, you get a black rectangle where you have the data you inherit. So what do you have here? In this black rectangle, you have space for age, then you have space for name, then you have space for bachelor program, and then you have space for faculty, which means this is how inheritance works. Every time you inherit that class, when you build a master student object, you get the same stuff as a student has. So you get this rectangle with all the small places where you have name, age, bachelor. And then, but only after you get this, then you get another rectangle which continues this memory space where you have space for the new stuff, which means now here you have space for master program, and then you have space for master faculty. So in memory, when you create a master student object, you get two rectangles. One which is the inherited part, which is this one, and then the second. And these are built in memory in this order. The first one is what you inherit, and the next is what you add. So this is the order in memory for this story. In order to give you the, let's say, the validation, if I will draw a PhD student, how a PhD student looks, a PhD student looks like this. You will have at the beginning a black rectangle. So I will just copy this one because it's easier. So this is a PhD student. Then, because a PhD student inherits also a master student, which inherits a student, then you have the orange rectangle. Let's draw this one because it's longer. So here I will have the orange rectangle. Okay. So this is the orange rectangle, which I need to draw again, which is what you inherit from the master student. So here you have it. Okay. So here you have the master program, and then you have space for the master faculty. Okay. And here, after this, you have the blue rectangle, which is the part you added here in the PhD student. So here you have the PhD program. So in memory, a PhD student looks like a student with some master data and then with the new data, which is the PhD program. Okay, so PhD program. Okay, so this is how they look in memory. And that's why when you create a PhD student or a master student, you also need the constructor from the student. That's why if you don't have the default one, you need to tell to the compiler which one to use. Because in order to create a PhD student, all these constructors work together. You have the constructor from student with the constructor from master student and the constructor for PhD student. They all work together in order to create you a PhD student. And this is the right order. The first constructor which is actually executed is the student constructor, then the master student constructor, and then the PhD student constructor. So when you create a PhD student, you are actually calling three constructors: the student, the master, and the PhD. And each constructor is responsible for its own part, for the attributes that you have defined in that class. Okay, so you have here a team of constructors working together to create that complex object which inherits stuff from previous classes. So this is how actually inheritance works at level of memory, how your objects looks into memory. Okay, so why is this important? Why is it important to understand this in order to give an answer to the question, can we store all this stuff in the same array? So let's try to be, which is not okay, but let's try to be ignorant. What it means? It means that if I ask you and show you this, let's use the focus, or how it's called, spotlight. So if I ask you and show you this in memory and ask you, hey, what's here? You will say it's a student. Then if I ask you, hey, what's here? And show you all this part, a black rectangle with an orange one, then you will say it's a master student, which is right. But if I will ask you what's here, and I will ask you to focus only on the first rectangle, what do you have here? If you choose to ignore the orange rectangle, what do you have here? It's a student. And if I ask you what's here, you'll say it's a PhD student. But if I ask you to ignore the orange and the blue part, what you will say? It's a student. So what it means? It means that despite the fact in memory you have different objects, bigger objects, if you choose to look at the first part, they are all the same. You see it? A student is a student, a master student, it's a student, and a PhD student, it's a student. So if you choose to look only at the beginning of each object in memory, you can say without being wrong, they are all students. Now, if you look further, you can say, hey, this is a master student because I also see the orange part. But again, a PhD student, you can say it's a student if you look only at this part, or you can say this it's a master student if you look at these two parts. And finally, you can say it's a PhD student if you look at all these three parts. So what it means? It means that in a framework of classes, you can choose to look at all this stuff from the parent perspective. And what is this? This is the upcasting mechanism. So if I go back to the source code, okay, so let's share again the source code. Once I understand how this stuff looks into memory, now I can say student. Let's create a student, a generic student. And in this student, I can use it to handle any other type. For example, I can say student equals Alice. But what's Alice? Alice is a master student. Now let's create a PhD student. So if I create here a PhD student, Bob, okay, then I can say student equals Bob. So at any point, you can easily convert any of your subclasses, any of your child classes type into their parent, which means because they all inherit student, a master student can be converted easily to a student, and the PhD student can easily be converted to a student. You see, this is called upcasting. Why it's called upcasting? We know what cast means, right? Because we know how to overload this operator. So why it's called upcasting? Because this is a cast going up. Going up where? In the framework. You see? You can easily convert a PhD student into a master student. You can easily convert a PhD student into a student. This is upcasting. You go up. Okay? So what do we understand? That in frameworks of classes which are in this inheritance relation, you can use upcasting. So what was our question? Can we create a single array in order to put here everything? Both students, PhD students, Erasmus students, or anything else. So let's say student 0. Let's move the toolbar again. It's annoying. So student 0 equals John. This is a student. Students, sorry. I already have a student variable. Okay. So John is a student. You see it? Then Alice, it's a master student. So let's put at students 1, Alice. Okay. And here I can say students at index 2 equals Bob, which is a PhD student. So what was the question? Can we have only one array of stuff to store here anything? So if you have a framework of classes, do you need to create arrays for each type? No, you don't. You can create an array of the parent type. In this case, student is the parent class for all our student classes. And you can store here everything. So working with frameworks of classes is not so difficult because you don't need to do this. You do it only if you want it. But other than that, you can have this mechanism, which is great. So I can easily create new classes, but from my perspective, I can have only one array type, which can be used to store everything. Perfect. So what's the opposite? The downcasting. Downcasting is when you want to get back your objects, which now you handle them as the parent type. So downcasting is the opposite. But this one is a very dangerous operation because no one will guarantee you that it works. For example, here, I want to say John equals with students. Sorry, not John, Bob. So let's create another PhD student. So here I will say PhD student. I don't know. John, Bob, Kevin, okay, equals with, and now I want to get my PhD student. So I know that in students at index 2, which is the third object, there was Bob. But here the compiler tells me, hey, it's dangerous. Because if you don't have here a PhD student, you can't convert a master student or a student in a PhD student. Why? Because you see, a PhD student requires 3 boxes, a black and an orange and a blue one. So if you don't have there an object which has all these 3 boxes, you can't convert a black box into a black, orange, or blue. So that's why this is dangerous, and that's why the compiler will not allow you, because here the program can crash. So here the compiler will ask you to confirm this. So you see that the upcasting is done automatically, but the downcasting is done, sorry, this is 2, it's done with this exception. And again, here, this is the new version of the compiler. It's forcing us to implement the cast operator in order to make this work, okay, on objects. Okay, so downcasting, let's say, works only if you know that uh, um, you can do the conversion. So downcasting is dangerous, okay? You need to be sure. There are ways to check it, but in C++, that will not help you a lot. Okay, so this is the upcasting and the downcasting mechanism, okay? So you have this mechanism here, which will allow you to change the way you see the objects. So what's this last thing with the virtual functions? So let's go back to the program. So right now we have a framework of classes, which is great. I can add new classes. Now I have seen that I can create a single array of stuff to put everything there, PhD students, master students, students. But now, how do you process them? So for example, let's say you see here in master student, I have a display method, okay? But let's say also here in student, I have a method which is, I call this void, no, string, or yeah, void get basic info, okay? Get basic info. And let's say that this basic info for a student does only this, end line. And here I will say it is a student. Okay, so right now in my parent class, in the student class, I have this basic info method, which means all our classes, master student, PhD student, they inherited. Let me prove you that. So Bob, which is a PhD student, now has get basic info. You see it? Because it inherits that from student. And also Alice, which is a master student, has get basic info. But if you run this program, what do we see here? So if I run it, okay, and then I will show you the output, you will see that all our students, master student, PhD students, they are all students. Okay, so how can I make this show different information for PhD students? So at this point, what will be the idea? I have this get basic info here in student. Then I can do in a master student, I can do this void get basic info master. Okay, and it doesn't look pretty. So here I will say it is a master student. It is a master student. So right now, your master student class has 2 methods. One method which is inherited from student, which is basic info. This is Alice, but now Alice also has get basic info master. And Bob, which is inheriting a PhD, Bob now has also 2 methods, get basic info master. But for Bob, this will show that it's a master student, but this is wrong because Bob is a PhD student. So what do you do? So this I will show you the wrong way. Okay, so what would you do now? You will go here in the PhD student class and you will make another method, which is get basic info PhD. And I think you get that this is a bad joke, right? So here you will say it is a PhD student. Okay, so right now, a PhD student like Bob has three methods. You see, get basic info inherited from student, basic info master inherited from master, and get basic info PhD, which is its own method. So if you have a very long framework, a very big framework, then you will have a lot of methods like this, which is, it's a bad joke. You see, you have all these get basic, get. So every time you need to do a method because you have something specific to show in that class, which is wrong. So if you see this as a bad joke, it is a bad joke. So I think when they design OOP, they also saw this fact that this is a bad joke. So they said, hey, this is wrong. Why should we have a lot of methods which have different names just to make these methods do something different for each class? Again, I will ask you, what would you prefer? To have all these different methods or to have only one? And if I will ask you which that method will be, I think you will all say it should be this, get basic info. So when you define inheritance, when you have classes which inherit other classes, you have the power to do this. And this is called overriding. You see, here you have this method get basic info in student. And now here, because we want to show in that method that this is a master student, we thought that it's better to have this method. Okay, so let's put here, not okay. But now if I understand that I have the power to rewrite, so this is overriding, don't confuse it with overloading. So this is overriding the method from parent class, which means now you have the power to take this method, redefine it here, and make it do something else. So this is a master student. So basically, instead of defining new methods in these classes, what do? You override them in order to have the same method name, but for a master student to do something else. And now you can do the same here. So here I will say not okay. Okay, so here I will override the method from the parent class, which is this one here, and now I will override it to say it's a PhD student. So now, instead of having all those very strange methods, now you have only one method which works for all these types in different way. So now if I run the program, here, you should see different messages. It's a PhD student, sorry, it's a PhD student or it's a master student, depending what's your object type. Okay, so this is great, which means that in a framework of classes, in order to keep the number of functions low, I don't need to define new methods. In order to have different methods, I can override the ones that exist. Okay, so this is overriding. Okay, and this concept with what you already know as overloading, this defines the biggest concept, which is called polymorphism. Okay, so here we added this overriding, and overriding plus overloading equals polymorphism. Okay, so this is the concept of polymorphism. Okay, overriding and overriding. But you see, overriding works only if you have a framework of classes. Okay, so this is the only way it works. But this is great for us because now I can have the same method which is redefined, so it will do different stuff depending on what objects we have here. So let's close the prepare to close the discussion. So what can we do? We can extend existing classes. We can create frameworks. Then using upcasting, I can define a single array where I put everything. And now I can have the same method overridden again and again in each class in order to keep only one method for all these types, but in order to make it different. So let's see if this works, which means that now if I go through that array, so if I say I at 0, I less than 3, I plus plus, if I go through my students array where I have a student, a master student, and a PhD student, and say students at index 0 dot get basic info, you see I have only one method. Now I should see it's a student, it's a master student, and it's a PhD student, which means with upcasting, with overriding, it's very simple to handle objects from a framework. So my program looks like we work with only one type, but because I'm very flexible with overriding methods, it works. So let's, I will put here an end line to focus on this message. So if I run the program, okay, and show you the output, you will all be disappointed because they are all students. But why is not working? Why I don't see PhD and master? Because we said, hey, here, I put here a student, this is a master student, this is a PhD student. Why here we see that they are all students, but here we have seen different messages. So why is not working? Again, the explanation is in the drawing. When you see, when we have created the array of students, that array in memory looks like this. You have an array of 3 students. So this is the first student, then this is the second student, and this is the third student. This is the array of students. So when we said, let's copy into the students a PhD student and a master student, what have we actually copied? You copied only the student part. So you see, when we said here, let's copy into students index 0, let's copy John. What have we copied? We copied this, which is John, and we copied it here. But then later we said, let's copy Alice, which is a master student. Let's copy it here. So what have we copied? We copied only the student part from a master student, not the orange. So that's why when you do upcasting and you have an array of objects, you will always lose the interesting part. You copy only students. So when you do this, in this array, you copied only the student part of the master and the PhD student, which means you lost the master part and the PhD part. So this is like a disappointing. So if we do this, we lose the interesting part. Yes, but only if you do this. But what happens if you do this? What's different? Instead of having an array of objects, of 3 objects, what do we have now? We have an array of 3 pointers. So how do you initialize now the array of 3 pointers? Yeah, let's say students pointers. So how do you initialize them? You get addresses. So now you say student pointers equals 0 equals what? Address of John. And then you say students pointers of address 1 equals the address of Alice. Okay, so this is upcasting at pointer level. So let's say here it's upcasting at pointer level. Here was upcasting at object level. And then if you say students pointers index 2 equals address of Bob, what do you get? The address of Bob. So what's different between this and here? Here, you are copying only the student part here because now you have an array of only black rectangles, only students. So this is the student part, the student part. And now what do you have? Now you have a different array, okay, which is of pointers. So what's the difference? When you store pointers, you store only addresses. So now this array looks like this. This is the first pointer, the second pointer, and the third pointer. There are no black, orange, blue rectangles. Here you have addresses, which means that now these pointers can lead you to the full master student and to the full PhD student. So this is my final argument why you should always play with pointers to objects and never with this. Because this is a dead end. You will never make this work as you want to make it work here. So let's test with pointers. Let's see if that with pointers now we can make this work. So I will do another test. And here I will say, let's go through the array of students, but student pointers, which means instead of dot, I will use arrow. Okay. And now let's see if this works. So I changed the perspective. Here I was playing with an array of objects, and now I'm playing with an array of pointers. And I see upcasting also works for pointers. So let's see if that now I have more chances to succeed, to make this work, which means I want to see here basic info for a PhD, for a student, and for a master student, okay? Depending on that. So if I run this program, okay, and show you, again, you will be disappointed, but this disappointment will last only for 1 minute. So right now I see again, it is a student. But if I go back to the drawing board, to the drawing, now what do you have here? This is a pointer which points to the student. And this pointer points to the master student. And this pointer now points to the PhD student, which means, hey, the student and the master student and the PhD student are there in memory. Why the compiler cannot see that? Because, as I said many times, the compiler, it's a very dumb tool. We are much more smarter than the compiler. At this point in our logic, we know that the second and the third pointer points to a master student and the PhD student. But the compiler does not see that. The compiler asks these pointers, hey, what are you? And these pointers say, hey, we are pointers to students. So the safest decision for the compiler is to get here, to ask here the method specific to the pointer type, because the compiler cannot see what's there. We know that in the second pointer leads to a master, and the third one leads to a PhD. But the student cannot see beyond this, that all these pointers are pointers to students. So if you ask the compiler what method should do here, should call here, the compiler will always say, hey, this is a pointer to a student. I will call the method from the student. But we know that we are very close to do that. So the mechanism where the compiler determines the type of the method based on the pointer type, this is called early binding. So in early binding, the compiler will always ask this variable, what's your type? And then the variable says, I'm a pointer to a student. And then now the compiler says, great. So let's call get basic from info. So how can we make the compiler smarter? You can't. The only thing that we need to do is to make the compiler not ask this question. We need to give to the compiler the method that we want to do depending on what actually object type we have there at that address. So how do you do that? And this is the magic moment. So I will run this program again. Okay, so I will show you again the screen. You see, it shows it's a student, it's a student, it's a student. And now this is the magic moment. We are very close to Christmas, but there is no magic here, only the Christmas magic. So I will go here in the student class and I will add this new keyword, virtual. So that's it. This is the only thing I did. Made this method virtual here. So what do I do now? Run the program again. And now, if I show you the screen, this is the magic. You see, magically, now the compiler is much more smarter and it will say the first one it's a student, the second it's a master student, and the third one it's a PhD student. So this is the magic of virtual methods, but they work only on overridden methods. So in order to benefit of this magic, you need to override this method here in the child classes. And then you need to define it virtual. So what's the magic? How this works? Why now the same program here works, but you see, made no difference for this part where you play with objects, with array of objects. And this is my final conclusion. So always work with pointers to objects, and this is how Java C# does. So you work only with pointers, but you don't see the star because this is a dead end, will not help you anymore. So you need to go here where you can benefit from virtualization, and now here you can benefit from that magic. So early binding without virtual. So now what happens? Now happens that if you have that method virtual, it happens late binding, and there is no magic in programming, only in your head, or you are the magic part. So what happens? What does virtual in order to make this work? Okay, so without, and this is with virtual. In order to make this works, this is what happens. When you make a virtual method, and I'll show in debugger, and this is my final comment. If I put here breakpoint, just to show you how a student looks like, and run this in the debugger, if you check the memory, now you'll see something different, which was not there before we use virtual. You see it? This VFPTR. And VFPTR is actually an array of pointers to functions. So now when you define a function virtual, each object will have the address of the function specific to its class. You see, get basic info from student is here. And now if I move to Alice, so let's move to Alice. So let's check Alice. You'll see that Alice inherits from student the VFPTR, but here on the same position, you have the get basic info from the master student. So now each object has this virtual, this array. Fortunately, we don't need to manage it, okay? Because otherwise this will be impossible. So fortunately, this is done by the compiler, but this is the magic which makes virtual method work. You have this VFPTR. If I go back here and I remove the virtual, so I don't have any virtual method in our class, there is no VFPTR. So you get this array of pointers to virtual methods only, you see there is no VFPTR here, only if you define a single virtual method. And if you have many, that array will have multiple. This is the master. So I need to put it back here. Okay, so this is how it works. So here, when you have virtual methods, the compiler does not ask this pointer, hey, what's your type? When you have virtual methods, this actually translates to this. Because now the compiler knows that the address of the function you need to call is here. So it does this. So it does not need to ask, hey, what's your type? The compiler knows that the address of the function you want to call here is in this hidden VFPTR attribute at location 0, because this is done by the compiler. So it knows where that is. So this is the way you should code from this point on with classes. You should create frameworks of classes. You should override methods in your child classes, and you should define your methods virtual. And in Java, you will see next semester, in Java, all the methods are by default virtual. In C#, Microsoft said, hey, you need to decide. So in C#, you need to decide which methods you want to make virtual. But in Java, they said, let's make them all virtual because we have only benefits. And in both languages, C# and Java, all your objects are actually references. They are all pointers. So every time you do this in Java, you are actually doing this. Okay, so this is the story with frameworks overridden and so on. Okay, so you see, like I said, it's 90% story. You need to understand how this works, and it's only 10% syntax. But you need to understand the story, how inheritance can lead to this, and how you can make inheritance work in your advantage in order to store everything in only one array. So you are using upcasting concept, and then you are using virtual methods in order to process everything as one. So you don't need to make very complex programs when you have complex frameworks. So this is what I wanted to show you. If you have any questions,